Hello everyone, so let's begin a new tutorial. So if I quickly brief what we have been covered so far, we almost done with our locomotion behaviors, plus we have a weapon equipping system and we can actually swap in between multiple weapons and locomotion system also is syncing with those equipments, right? So I think so far we covered all this stuff relevant to the player character, uh, and I think this would be a good place to sort of focusing about NPC characters, right? For example, like in our game, there can be enemy AIs or maybe let's say allies that can be actually team up with, or like there can be any other neutral player characters or NPCs like maybe like citizens, uh, things like that. Right. So let's look into those NPC AIs now. Right. So to get start with, I think we can go to the TPS games folder, and inside the characters, if you go to the blueprints folder, we have this hierarchy, right? So we have our base character, and by using that base character, we implemented our player character, and we have initialized the blueprint for NPCs as well in its base folder called NPC base. But currently this one actually wasn't implement nothing much, right? So if you check out its blueprint, there is nothing, right? Because by default we inherited this stuff from our character base and we have only those items in, right? So I can go to the character base as well and show you what we have. So basically like yeah, we don't have nothing much here. We just attach the component structure, right? Plus I think we don't need this one anymore. I just added it just for the debugging purposes, right? But if you look into the player character base, then there are some implementations going on, right? So mainly like we have the player control initializations and we have the input consuming features, things like that, right? But yeah, so what I've been interested in this blueprint from now onwards until a couple of sections, right? So to get start some of these stuff, I think I'll create a new level, so it would be easier for me to explain certain stuff, plus it'll be much more organized, right? So I'll create a new folder called NPC, and there I'll create a new level, which is a basic level, and I'll save that current level into NPC folder. I'll call it as map underscore NPC, right? So if I play it now, it's something like this. Okay, so now I can actually place one of my NPC bases here and see what happens, right? So you can see the NPC character also is in the idle state by default because the locomotion system default state is idle, right? Plus since we follow this pluggable architecture, actually we can quickly set up whatever the weapon this guy carries on or things like that, right? For example, Like I can go to this instance and select its weapon system, and I'll add maybe a rifle, and I'll make the default weapon slot as 1. If you play it now, you can see by default that character is actually equipping the rifle, but suddenly he's moving to the unarmed state. Yeah, I think this is a potential bug we can resolve. So if you go to the, let's open up the blueprint. Right, let's open up this firearm weapon base. Okay, and it has the parent function for weapon base. Right, so the rifle is actually set up the name set of rifle, which is correct. I think the issue is at this BPI equip. I'm not quite sure. Set anim set. So let's try to debug it from here. Which anim set it initialized at last? Yeah, I think we'll increase the duration. And get the owner as well, and append it together, so we can actually visualize like what is the owner and what is the anim set accordingly. Right, so you can see it calls twice the rifle state and once the unarmed state. Yeah, for the NPC character actually. I think the issue is at yeah, let me debug it. Right, so I think I found the issue. Well, it's sort of a race condition issue. So if I explain it here, basically like if you play it right now, you can see like the character goes to unarmed state, but the rifle is equipped, and the print statement actually print the last anim set is rifle, right? So what actually happened is like at the weapon base it tries to manipulate the anim set, plus at the character state, which means at here at the character based locomotion system also it tries to sort of initialize its own default anim set, right? Because you can see at the component subsystem locomotion system at its begin plane, here we set the anim set right after this delay. Actually that's the reason it has this issue, because soon after the weapons has been initialized, after this duration it caused this initialization again, which ultimately changes anim set back to the default anim set, right? So as a workaround, what we can do is we can simply get rid of this delay and plug it directly like here. If I play it now, you can see now it works properly, right? So we doesn't encounter any issues. Right, so I'll remove this delay, compile and save. Okay, so I think it's sort of good to have such a bug, because then I can explain such scenarios, right? So when you're using those sort of delay pins, sometimes it gives some issues, right? So make sure you are using the delays only when it is required, right? Okay. Right. Okay. Then what I can do is, actually I just wanted to show you its features, like how quite easy to configure our NPC characters because of this data-driven pluggable architecture. But I'll remove this instance from the level, and instead let's create a child instance using our NPC base, right? So I'll go to the NPC base implementation level and right click on it and select this create child blueprint class. So it will create a child blueprint instance for you, and I'll name this as bpnpc. Maybe I'll name this bp enemy, right? Move it outside the npc folder, right? Now I'll open this one, and there let's assign its weapons. So as the weapon system weapons, I'll assign maybe a pistol this time, and the default weapon slot is 1. Compile and save and drop it to here. Right, now you can see actually the character is equipping the pistol. Right. First, let's get rid of this print statement. I just added those stuff just to see how it works, right? So I will remove these pins at the set and im set on BP weapon base. Okay, now we don't have any debug text. It's been printed on this screen. Right. Now let's try to move our character in within the level, right? Maybe for some random locations. So in order to do that, usually we have to follow sort of a procedure. I can actually simply tell here, for example, like AI move to, but this is not the optimum way of doing those AI movements, right? Because later on actually we are going to add many complex AI behaviors. So I just needed a way to sort of hierarchical way of managing AI states. So in such scenarios, actually we can use behavior trees, right? So let's add a behavior tree to move our NPC. So I'll go to the characters NPC folder, and inside the base I'll create a new folder called AI, right? So all the features related to AI behaviors I'll organize that here, right? So before creating a blueprint, actually in order to control our NPC character explicitly, we have to create the AI controller, right? Similarly what we have been done for the player controller, right? For example, at the game base we have this TPS game PC, which is a player controller to control the player character, and similarly we need a controller to control our AI character, right? So I'll select the blueprint class and search for AI controller. So at the hierarchy you can see multiple different options. Either you can select this AI controller, or I suggest you to select this detour crowd AI controller because it has sort of a good way of handling like collisions and all, collisions and blockings and other stuff. So I think using this detour crowd control AI controller would be fun. So I'll use that one, and let's rename it as BP NPC AI controller. right? And then at the event graph, at its begin play, I can print a statement called hello and see whether it's working properly. But first I had to plug this AI controller to one of our NPC. Therefore I'll choose this NPC base, right? Because that's our uh, parent class for NPCs. So all the NPCs will be automatically inherited this play controller or AI controller by default, right? Then select the base class defaults and search for AI controller. So you'll see under the pawn category, we have this AI controller class, which is by default AI controller. But what we need is our own AI controller, which is BPNPC AI controller. Okay, let's compile and save and let's play. Now you can see the hello statement is being printed, which means our play controller is attached properly. And then what we can do, we can sort of run a behavior tree, right? So in order to run a behavior tree, I'll go to the AI controller and create artificial intelligence behavior tree. And let's rename this as BT NPC. And here you can see now this is sort of a tree data structure that we can compose multiple different AI behaviors, right? But for now I'll just keep it as empty. And let's go to the AI controller. And instead of using this begin play, I think we can use event on processes, right? So whenever the AI controller get the control, we can run this behavior tree, right? Okay. So I'll promote this to a variable as well, because later on actually you can use that reference. And let's use run behavior tree function. And as the behavior tree asset, I'll use this BT NPC. Okay. Now this behavior tree will be triggered, but currently it doesn't have any implementation, so I can't show you what will happen. Therefore I will add a wait for now, right? So in order to add a wait, first let's add a sequence and then let's call wait, right? So this is simply a waiting behavior where the NPC is actually remaining on its own position, right? So if I play right now, and I'll sort of minimize the screen and show you the behavior tree and the gameplay side by side. So you can see actually now the behavior tree is being invoked, right? So that yellow path where the white dots are moving is the path where this NPCI character is being executing right now, right? So his entire behavior will be driven by this specific behavior tree action, right? Which is currently waiting, right? And let's say if you want to move this character, there is a function called move to. You can select that thing, but currently doesn't serve any move to location if you plug it like this. But if this move directly towards here, but it also doesn't implement, yeah, it won't be moved. Right. Anyway, like we can actually use this move to sort of a node to direct our AI character and tell where to actually move, right? So the reason this one is invalid because we haven't set up a blackboard yet, right? So here you can see like there are two options that you can toggle. First one is behavior tree and the second one is blackboard, and this blackboard one is grayed out, right? So let's set up that one as well. So I'll select blackboard and call it as bb npc, and then I'll open this behavior tree and select this root node, and as the behavior tree blackboard asset I'll choose this one, right? So now you can select in between these behavior trees and blackboard, right? So if I give a brief intro about what is blackboard, blackboard is uh, sort of a context where we hold the npc related uh, variables or like states, right? And essentially behavior tree will read those variables from the blackboard and perform certain actions, right? That is sort of a way, right? So it sort of work back and forth, right? Either you can take the variable out of the blackboard or you can even reinitialize the blackboard variables by using the behavior tree, right? Now you can see the move to option has been enabled, and by default the blackboard key is self factor, right? Because here the default key is the self actor, right? But I don't need to use this actor reference. I just need to move my npc character to some location. Therefore I'll add a new key which is vector, and I'll call it as move to location. Right, so this move to location now can be set at the behavior tree. So if you select the move to and the blackboard key which is move to location, you can see it is targeting to this specific vector, right? So it will wait around 5 seconds and move to this location, okay? But I think 5 seconds is a bit too much, so I'll make it as with 3 seconds, right? So it will wait 3 seconds and move to this location, wait 3 another second, move to this location, right? And currently the move to location is basically I think 000 by default, right? Which means ideally the character should move sort of uh, origin point, right? Okay, now I'll play test. Here you can see it wait for 3 seconds and suddenly the move to function is being called, but the character is not moving, right? Because we haven't added any navigation volume to our level, right? Otherwise, if we haven't a navigation volume to our level, the npc character may not able to actually find out where to move. So in order to fix that, let's add a volume which is what now mesh bound volume, right? And I'll make it to the origin point and let's scale it further. So as the brush settings, Here I'll make this as 2000, no, 5000 by 5000. Yeah, and I think this range would be fine. And if you select actually the P key on your keyboard, you can see suddenly that area has become green. Actually, it's to visualize the navigatable radius or navigatable area of your level, right? And if you can press the P keyboard again, so that debug option will go away. Right, so let's play it now. So I'll open this behavior tree as well. Yeah, actually you can see that move to location is called suddenly, but the character is not moving. Okay, we'll see why. Right, so the reason is actually this move to location is not initialized, right? So we just plugged our variable and it doesn't actually have any initialized value within that variable instance, so it doesn't know where to move exactly, right? So for now I think I can go to the AI controller, and here I can like tell where to move, right? So I'll simply use the blackboard, right? Blackboard variable, and let's set value as vector, and as the key name I'll make a literal name, and this name should be whatever the name that we used here for our variable. So in my case it's move to location, so I'll copy that thing and paste it over here. And as the vector value, for example, let's say simply the origin point 0 0 0. Okay, right, now if I play, you will see the character is actually moving, right? Wait 3 seconds and it can't move again because it has been already reached to that position, and I'm not actually reinitializing the variable as well, so it simply stays there, right? But you can see actually the character is moving, right? Plus it's not perfect yet. You can see like the character is sort of sliding through the ground, which is not acceptable, right? So we have to resolve that as well. But ideally what I wanted to show you some of the basic features that we can do by using behavior trees, right? So yeah, I think as a startup, this be a good position to stop our NPC initializations. And yeah, I'll see you in the next one, and we'll improve this AI movement logics further. See you there. Thank you.